Hey guys, welcome back to the channel. I have another computer repair video here. This one is for Chris Arizola from Texas. He sent me two computers. One is for a 2012 Grand Cherokee, and the other one is a transmission control module. I have not even started yet, but this is the module that we will be testing probably next. Um, right, so he's concerned in this one. Let me see what I did with his paperwork right here. Make sure I can cover some of his information. Give me 1 second, guys. All right, like this we can all read here. So we got a 2011 Silverado, Allison transmission, no communication. So again, I have not started that one. And then we have the 2012 Jeep Grand Cherokee Overland. That's a 5.7 and cycling ASD relay. All right, so I have everything ready to go, and I have even the top done, which is the one I love to use always. This is my favorite tool to use here. So what I will be doing, let me move this a little closer. All right, seems like I lost communication. So if that is the case, what I'm going to do is I'm going to start with the normal way of how I do things. So let me get out of here. Like that we started communication and everything again. You'll see it shows even the VIN number that we have in there, but I'm going to start as I always do. All right, guys, again, just to show you everything as I normally do, I have the screen recording going on. As you can see, I did my homework, and this time I just actually just did on one of the PDF, and then I created all the pins that I need, powers, ground, ignition. As you can see here, this is a computer that uses four connectors, 38 pins. I have it here. C1 should be the black connector, C2 the orange connector, C3 is the white or natural color they call, and C4 is a green connector, and the connectors will have that color. I can actually show you. I think I have a picture of the computer. Yep. And let me just focus in here so you can see again green, white, orange, and black. And they call this black, and that's why sometimes I get a little confused when you're seeing on this, because why they don't name this one white, no idea, but they named this one black, and it has absolutely no tape or anything on it, so you will see like, well, which one is which, right? But so if you're seeing this, that's the way they are. All right, so you can see I got multiple informations. I had, the connector one. Yeah, let me just show you that in a second. Again, specifically with the beam. A nice thing of this, it shows me the pinout, which is in this case is pretty easy. With these connectors are really easy to understand. They even have the numbers in there. And this is nice about ProDemand, and I think Identifix, and hold on, I will give you this on Jeep, or well, let's say this is the nice thing about Jeep, is that it actually shows you the location of the pin of the sorry of the connector. So C1 is facing the computer up, and then you will have, because the computer has like a long bottom and a short top, and then that's the way the connectors are there. So you can see which one is C1, and then going down, um, you can see which one is for the 5.7, which one is for the 3.6, and then you can have all the pins in here. These are all the pinouts for the entire vehicle. Like I said again, did my own page because I don't need the entire vehicle here. So I need to have powers, and I can see, as you can see, I also put in C1, 10, and 30 are not shared sometimes. Powers and ignitions and so on, or sometimes like let's say, these C110 and the C130, they're both are called battery. They're like a keep alive memory battery power, but they're not shared internally in the computer. So I have to actually supply those two, and that's what I put in there as not share, not share. All the ESD F. If I go over to the to the diagram, let me just go over to one. Like if we see here, C38 is called ASDF. If you go over to here, so in C31, what was it, 38? Yeah, 38. So if I make this bigger, I'm sorry about that. not in program man that you do it like that. So we can see ESD control feed. That's what that says. So, and if I follow that wire diagram, which since we're doing this, let me just show you because I have it saved. And as you can see, ASD relay power feed mark. What I do is in Identifix, I can select the wirings like now you can see with the yellow mark in there. This will let me show you because all this, like I said, is interconnected. Same thing, you will do it on the computer. So we got the ASD control feed, again, C31. If we go over to, looks like C2 doesn't have one, but we can see that this comes over from um, these fuses that are actually going through the auto shutdown relay. So when this relay closes, it will energize because we got it hot all the time. I'm sorry, I'm trying to move that so you guys can see here, hot all the time, and then it will supply the power through this terminal 30, and then going out into 87 and supply the power for those ESD feeds for the computer. If I go over to the next page, which I have here, it just goes through here. And in here, we can see it supplies power to all the, I think it's injectors and coils. So this is part of what is being supplied. Again, anything that is marked in here is part of that. So we have, again, since this is a dotted line, it doesn't make it together, but it's, as you can see, together. Let me just see if it, yeah, I didn't mark it in here. That was my mistake, but you can see this brown and white. Again, I'm going to move the mouse so you can see where I am. If I go down in here, it's also supplying power to all the fuel injectors and all the coils. So ESD is in control of the power for the injectors and coils. So going down into the last, actually it's 5 pages, so this is not the last. This one just goes through. And then this is the last page, which comes back to the control module, and then we have two more cables on C3, again 19 and 28. ESD control fit one. I don't know what they name it, fit one or two or whatever, but they're all the same. And I checked that there is nothing on C4. And then if we go over to my connections, we can see that, C3 has 1928 ASDF and C138 ASDF, all share, all these ones are share. And then in C4, we got another battery voltage, let's say, and it's 1928 and 38. There are share in the board, and that's what I put them in there like that. Again, these are the grounds are they're all share across the computer. So I put one ground in connector C1 and another one in connector C4 just to give extra ground for the test that I have. I don't really need that much. We have all the injectors, all the coils locations that are in C2 and C1. Same thing with the coils. That's not what I meant to do. Communication wise, we have CAN high and CAN low. They're in C134 and C135, as you can see here. I marked two 5-volt reference. I have not checked those. Well, I checked that they're not shared here, but they might be going into the voltage regulator, and the voltage regulator is the one that's taking it takes charge of that. This is the voltage regulator right here at the bottom. All right, so we got the sensor ground, coolant temperature sensor, fuel pump relay, and ASD relay. Those are my important signals for his concerns. All right, so that's as much as I want to show here. I can go over here. This is the one that has the ESD return, and that's how they name it. Again, I don't know why, because it's just the control wire. Um, As you can see here, we got pin 86 on the auto shutdown relay. Again, I'm in the top. Hopefully you guys can see that up top. I'm moving my mouse so you guys can see it. We're gonna follow this yellow line. So I got a two-page view in this case, and it's going to go just through here and going down. Oops, sorry, too fast. It just goes through the next two pages, and then at last goes into the computer again on the connector C3 terminal 3. And that's how I have been marketing here, right? So ASD relay is C33, and I put that minus sign in between those apostrophes, or not apostrophes, parentheses. And same thing for the fuel pump relay there, ground size control. And that's what I did here. We can see if I go, yeah, we got the fuel pump relay with this the same 86. So 86, if we keep with this same 86, 85, 30, 30, 87, they're using 85 for power and 86 for ground. And then that's a way that I know that both relays are indeed ground side control. All right, so this is, I think, as much as I want to show here. We can go over to the oscilloscope, which I have right now. Picoscope ready, connected to the fuel pump relay and to the ESD relay. So the blue channel is, I can put notes in here. Yeah, so we're gonna put, at the bottom. Blue channel is the ESD relay, and then red channel is the fuel pump relay. Sorry, took me too long. But yeah, so right now they're in 12 volts. We can see that. So the normal stage, actually that 12 volts is coming from the simulator, waiting to be pulled to ground. That will be the same way that a working relay without ignition on should be, right? So right now the computer is on. The only thing that I need to do it will be to connect this scanner, but I want to turn this off. As you can see for a second, they both the ESD and the fuel pump were on. And that is normal because I'm not going with the correct procedure of the key on the vehicle when I'm do this. So if I go with a tree, fuel pump relay and ESD relay should go on for a brief time. We will calculate in a second, and then they will have to go back on. I mean off. In this case, activated will be down as closest to ground, and then off when they're power, right? All right, so I'm going to run this now, and I'm activating it now. So we can see, let's see for how long they're going to stay on, and that's it, right? So we can now stop this capture just for a second, because then we can put cursors. We can separate the channels. Where is the red channel? And then you can see that they're indeed being activated separately, right? So we can, since it's happening in the exact same time, I have, 2 seconds per division. So they're being active for like almost 4 seconds. Let me see, what is 3.1 seconds? So they go on for about 3 seconds, 3.1 seconds. So, and I can see that if I take you guys, let me just get the camera 1 second. I'm going to do the same thing that I just did. And I have, again, I name it this one. It's called actually AC relay, but this is for the fuel pump. And then the main power relay, which is called main power relay here, is for the ASD. So you will see main power relay and fuel pump when I do that same activation in here. So let me close this a little bit. So I'm going to turn this off. This is for a brief second they were on in there, but okay, now this is off. I'm going to turn it on, and we will see again. Remember these two tapes in here. And they're, like I said, that they stay on for like 3 seconds and they're both on. So that's the first clue that they're working. So there, I don't see nothing wrong, at least not yet, with this system. His concern is the ESD relay. So I will be doing a test. Keep you posted always, no matter what. The screen is being recorded. So let me just run this. So we got again. I should have kept this too because that's 12 volts and 12 volts, so we can see more graphically when they come on. This just went off. So I'm going to sign in again, do the vehicle scan. That first sound is a scanner communicating with the BCI Pro. That's the sound of reading the VIN number. I'm going to put it here so you guys can see that's the VIN number. And if I read the page, let me make sure that this is indeed the VIN number that we have. It says 294727. That's exactly the VIN number. All right, guys. So I like this scanner because it's nice and big and you can see it really good. Hopefully, I will just probably stay here. Um, I don't know why I didn't want after this one. Are you sure you want to exit? No. Usually, when it reads that, it goes to uh, the car. So let me exit again. What's going on? You read the bin, should go, and that is definitely the scanner because usually, let me see if you guys are seeing that in there well. Yeah. Okay, now see this time it did it. And when it reads the bin, it doesn't, and it goes to the next page automatically. I don't know why I didn't do that. I guess a glitch on the scanner. I just usually go over to the quick access in here, going to make sure that your selection is correct. There is nothing else connected. This is just Jeep stuff. We're just going to click OK onto all that. We know that it's correct. It's the right bin number. Come on. Again, this is just normal thing. If this will be on the car, it should go first through a VCM and then to the PCM. Not a problem in this case. We're gonna select the PCM. I wanted to have the fuel pump control. I don't know why in the actuation test the fuel pump is not there. So we're gonna go on the ASD relay SND here. Let me just see if I find it again. Okay, right here. Okay, so select the way to start the actuator. So we're going to go over to the data stream. There is only three things, or two, three things that I want to select, a maximum of 10. So we're gonna go over to the ASD. This should be alphabetically ordered. Um, Send switch filter state. No, we just need the actual state, and let's look for the fuel pump as well, because then we will see if when the fuel pump changes. Because I have the state right now, so they're both false. If I toggle on, you see it's now on, and we can see on the scanner that is actually it did the two activations. Something is going on with the communication because you saw how it was like a little slow. It wasn't showing the on position. It went to off. So we can see that in there, right? So we can see that I can toggle. I can actually toggle it here. That's by the scanner toggle on and off. That is the ESD relay, or is that it? ASD relay. Sorry, sometimes Spanish English mixes in my brain. But so we can see that it has plenty of control. So this something I will like to um, run with Chris because I truly don't see anything wrong with this. He said that they replaced the computer and the car is now working perfectly. And that's his own concern. His only concern is cycling ASD relay. I don't see that here. All right, we got a call. I have a call. Let me just do this test again briefly. What I was trying to say is like if I cut the power here, we will be able to see that on there and in the scanner when the both relays are closed. So very briefly, you can see through, and then it's through there, and then false when it goes over to, off. One thing that I want to check is in here, compare, tomatoes to tomatoes, is that are both relays being pulled down the same amount? And I thought it was because they were perfect images, right? Kind of. Even the ASD relay is the one that's being pulled more. So let's see, the ASD relay is being pulled to 700 millivolts. The fuel pump relay is being pulled to 786. So again, I don't see anything wrong with neither one. And I can just leave this on. And as you will see, now the ASD is being pulled. The fuel pump is not, obviously, because we're now commanding it with a scanner. Not sure what this problem was in his case, but I don't really see nothing wrong with this computer. Not that, not with the circuit. His concern is the ASD relay is working 100%. I'm gonna try to do something. Um, One thing that I wanted to know is how much is my test lights drawing? Because I don't know if you guys remember last time when I did a test on, but those were going through a voltage regulator for the Mini Cooper. Let me check here for amperage. I gotta go common, and in here, look like this one they don't have milliamps. Huh. All right, so I want to get a rough idea of how much these test lights that I have here draw. Um, I can just go ground on one side. Let me just think on this because I can. All I'm doing is just checking my test light. I'm going to use my meter as a bulb. So we have power on one side, right? And then it's going through the meter, and we're going to use the ground. Uh, Let me use the ground because that is not on. So let me use the power here. Forgot that bottom part, that bottom simulator is not on. So let me connect the power, and it draws 264 milliamps. Not really much, right? Hopefully you guys can see that there. So again, I'm just checking the test lamp in here. Might be a little off camera right now. Oh, do you guys see that in there? No, it shouldn't, right? Thought I saw something in there. All right, so all these should be good to use. All right, so what I want to do is I want to move. I don't need that one for this one. I put everything on my meter back, and I want to make sure that I move this to the other side. Always be careful when you use a multimeter for amperage to move the leads out of amperage and to set the stop back to where it belongs. So I'm going to move the ASD relay, in this case here. You'll see that we're going to even lower because it's now not connected to the simulator. I keep trying to use this. All right, so I'm going to go over to power right here, and we're going to use this here. And as you guys will see in a second, it is able to put in bright the light. So the computer is grounded 100% that ASD relay. So just like I said, sometimes it depends on the application. You will not be able to do the test. Like in this case, this is a solid state device inside the computer. Computer is a heavy driver, so it's not a problem. And should, okay. Now we duplicate it. Let's just stop this and let's go back because it looks like now it cycles. Perfect. I needed a load. You see, guys, this is his concern. This is why it's so important to do a loaded test in devices because remember, this is still on. I guarantee you that if I remove that from there, this will be working, no problem at all. So let's turn this off. Make sure it goes to off position. Let me save this. I want to save this file. So 2012 Grand uh, Test before repairs. Uh, of what, right? ASD relay. And can I set how many samples we got here? 12. I want to save all, so with test light, I'm gonna save it all. No matter what, we have the video to remind me how the test was being done. Because if we go back in the capture, we can see exactly where these was not connected. Again, this isn't zero right here, right? Zero, almost perfect zero, which is impossible, right? And then when I plugged the light, the test light, we briefly went up to battery voltage again in here, and then it was able to pull it. We saw a few glitches in here, but the computer was able to pull it pretty much, well, 1.1, but the light was very nice and bright, right? We can see that the battery voltage went even higher. We have supplying 13.5, which is perfect. Um, let's see when and how long was on. So we got 2, 4, 6, 8, 10, 12, 14, 16, 18, right? Yeah, so we got 18 seconds on this one, and 2, 4, 6, 8, 10, 28, almost 30 seconds. That's what it lasts, 30 seconds to react. So I'm going to get more seconds per division, so times 10, that will be 50 seconds on the screen. This should be good. All right, so we can just want to do the tests again. Right now this is off, so let's try to see if we can turn it back on. And it did. As you guys can see, the light is on. Let's see how long it will stay on. Because also remember the test might have timeout, but it wasn't saying timeout. It was saying just uh, in here was saying on and false in here. So I don't think it was because it got timeout. I think it's because it's actually a glitch. I got 25 seconds. I should have given more. Well, either way, it's probably going to happen on the next screen if this happens again the same way. But I'm so glad that I'm using the load because that's a very visual, not just only the oscilloscope, because sometimes, again, we can see the activation of the oscilloscope, but without loading the circuit, it might not be the case of, making it react. Definitely it's lasting longer on this time. I'm going to keep doing this test. If it happens more often, I think I'm just going to stop the video here. I think this is a good test for what we were doing. Let me grab the phone. So yeah, I think that this is a good test for what we're doing. I am still with a good through and not false like before, but I'm glad that I was recording because we caught it in the moment. So I want to revisit the video and then see what I can see because I also want to use the phone with my thermal camera to see if I can see something getting warm. If this is the case, I will probably just add those pictures onto the um, bonus material that I always do, or I even put them in the same video as I am describing right now. For the moment, let me just stop the video. This will be part one testing this 2012 Cherokee 5.7 for Chris Arizola, Texas. Talk to you later. Don't forget to subscribe. Thank you so much. Bye bye.